morning. Thank you for joining us. My name is Grace Schiebel. I'm the project manager for HHBS Engineering, and today we are here to give our final presentation over the Brooks subdivision development. So first off, I'd like to introduce our team members. We have Jabril Hoskins, who is our environmental engineering lead, Andrew Hernandez, who is our transportation engineering lead, and I'm our structural engineering lead. So our project is located in Valparaiso University, just north of Valparaiso High School. The land is being developed for residential use, and the project will include the design of a two-story visitor center, the design of roadways, pedestrian accesses, and a parking lot, and the design of a collection system, lift station, and bank stabilization system. So moving into the structures portion, I was tasked with designing a two-story visitor center. My square footage requirement for the main building was supposed to be 40,000 square feet with a covered outdoor attached space with a square footage of 1,200 square feet. My finalized design footage came out to be 450,000 square feet for the main building and 900 square feet for the covered outdoor attached space. The reduction of size was just due to the beam layouts that you'll see. Next. The project location is the northeast side of the project limits. This is due to the developed subdivision to the east of this project site. That way both communities have access to this building. So starting off, I'd like to go over a review of my loads. The wind load that was found was 26.58 pounds per square foot, as well as the snow load being 46 pounds per square feet. The applicable dead and live loads are found on the screen above, which was used for the design. I also include my ASC hazard tool values that I pulled from the ASC website and any of the wind and seismic values that were inputted into my RISA design. So this is the structural member layout for the first floor. This shows you locations of where beams, columns, and girders are being placed, as well as where my brace frames are located, and basic sizing for the building. Same thing, but this is for the second floor. The only difference between the first and second floor is that the covered outdoor attached space is no longer included. So that the sizing stays the same. So for my foundation design, I'm doing a concrete slab on grade. It's going to be 7 inches thick, and it will have rebar that is number 4 bars at 12-inch spacing. This is my detailed framing plan for the first floor, just showing you the member sizes that I selected for my beams and girders. Basic sizing stays the same, and just, yeah. This is for my second floor. They have changed due to loadings on the first and second floor being different. This shows you a more detailed look at what the building looks like when you're standing out front of it, just to show you where the loads are being placed, as well as the elevation of the building. The first floor will be 15 feet tall, and the second will be 10 feet, as well as where the brace frames are located. This is for the east and west side, standing looking at the building again, showing you where the loads are being placed, as well as where the brace frames are located. And the sizing stays the same for 10 feet for the second and 15 for the first. So this is a more detailed look at where the members selected are located. This is for the east and west side of the building, showing you the columns, the girders, and the beams, and what the member sizes were picked out. And this is for the north and south side. This also includes the outdoor attached space on the building, which is 30 feet long. So my material cost estimate came out to be about $1.1 million. This was used for RS Means line estimator. However, to get a better idea of what the actual cost of the building is, I used RS Means square foot estimator to get approximately $4.4 million to really get an idea of the other materials outside of the framework that will be added to the building. At this time, I'd like to hand it over to Andrew.
Okay. So I'm responsible for the design of 2 new roadways, Bell Park Road and Old Oak Drive, the intersection connecting the 2 roadways, the pedestrian paths alongside Bell Park Road, and then the parking lot on the east side of the site for the visitor center. Here is the design criteria table for Vale Park Road and Old Oak Drive. This design criteria is reflected in the technical drawings that I will show you in this presentation, and this information has been derived from the NDOT design manual. So we'll start out with the typical sections. Here's Vale Park Road's typical section. It spans 71 feet in width, with your 10-foot wide pedestrian paths on either side, 5-foot grass buffer, your curb and gutter drainage, and then 3 12-foot wide asphalt lanes. As far as material depths go for these lanes, we have 5 inches of number 53 aggregate, followed by 3 inches of base asphalt, and then 2 inches of surface asphalt. Looking into Old Oak Drive, it's much more narrow, with just your curb and gutter, and then your 2 11-foot wide asphalt travel lanes, and the material depths for those are 3 inches of number 53 aggregate, followed by 3 inches of base asphalt, and then 1.5 inches of surface asphalt. Taking a look at the intersection of Bell Park Road and Old Oak Drive, it's a stop-controlled intersection with Old Oak Drive stopping for Bell Park Road. As far as the turning radii, they're 50 feet, which accounts for the single unit design vehicle for this project. Looking at the turn lanes, the storage length is 75 feet to allow vehicles to queue before making their turn movement. And then there's pedestrian crosswalks and ADA plates to allow pedestrians to safely maneuver the intersection. Looking at the alignments as a whole, starting with Bell Park Road, it begins on the west side of the site from the existing neighborhood. It moves towards a horizontal curve with a radius of 450 feet. Then you have your intersection near the middle of the alignment, another 450-foot radius horizontal curve, and then it ends on the west side of the site with your parking lot for the visitor center. Looking into Old Oak Drive, it starts from the south of the site, from that existing neighborhood. It has your two 300-foot radius horizontal curves, and then it meets up with Old Oak Drive near the end of its alignment. Taking a closer look at the parking lot, it has 167 spaces, 10 of those being ADA accommodated spaces. As far as the driving aisle widths go, it's 22 feet. And as you can see, there's a big pedestrian crosswalk area near the entrance to the building, which will warn drivers, there's going to be a lot of pedestrian traffic in that area. And then this parking lot has pedestrian access to a pedestrian path alongside Bell Park Road to ensure that people don't have to walk through the grass to get to the visitor center. Finally, we'll go over the construction cost estimate. I'll talk about some of the major costs, starting with the roadway costs. It totals to $840,000. That's for the materials and the labor that goes into putting down your roadways. Another big cost was the earthwork, which totaled to over $1 million. This is because we have a completely undeveloped site, so a lot of resources are going to go into ensuring that we have a smooth surface for our roadways. Other costs include drainage inlets, culverts, signage, miscellaneous items like that. With the contingency, we have our total cost estimate coming to around $3 million. Now I'll pass it to our environmental engineer.
Thank you, Andrew. As mentioned earlier, my name is Hoskins, and I am the environmental engineer here at HHBS Engineering. To quickly recap my scope one last time for you all, I was tasked with designing a wastewater collection system that includes sanitary manholes, a lift station that has a force main, as well as a bank stabilization system. All of these tasks must be in compliance with the local and federal regulations that are shown on the screen. In the last presentation as well, I showed you all my design criteria, as you can see here, and today I'll be showing you all how exactly I follow through on the design criteria. Taking a look again once more at the plan view of the collection system, as indicated by the purple lines, those are the pipelines that are running through the subdivision. The red circles indicate the manholes. In this case, they're placed at the junctions of the pipe networks. Note that there are more spaced throughout the subdivision. You will see that on the next slide. The lift station is indicated by the orange box in the bottom left corner of the screen, and then exiting that lift station will be a force main that discharges the wastewater from the subdivision to the subdivision that is south of the project site and occupied by Hampstead Court. This slide here shows you all the profile view of the collection system. This came from Bell Park Road. As indicated again once more, the purple lines are the pipes. Between those, or on the outside of the pipes are the manholes, and then the rolling elevation is indicated by the yellow line, and then the ground elevation is indicated by the green line. Shown here are the manholes that are spaced throughout the subdivision. The inner diameter was determined to be 4 feet, the outer diameter was 5 feet, and then between the inlet and outlet pipes of the manholes, there's a 0.1 foot minimum centerline drop. That is in compliance with the Indiana State Department of Health regulations. The reason why they have that there is to prevent any backflow moving the system. And also, as shown, precast concrete manholes were selected because they comply with ASTM C 478. This slide shows you all the pipe flow conditions. My main thing here is to highlight to you all the flow velocities as well as the pipe diameters. So again, my flow velocities need to be ranging between 2 to 10 feet per second. And as you can see, the flow velocities in this case range from essentially 3.5 to 7 feet per second. Do note that in that calculation, via Manny's equation, I did vary the slope between 1% and 1.2%. This is to allow for additional flow throughout the subdivision. And then the force main was calculated to be 4 inches. This is the minimum pipe diameter allowed by Indiana. It's calculated that it was an iterative process of using Hazel-Williams equation. And then the pipes underneath the Bell Park Road are 8 inches. The pipes underneath the Old Drive are 10 inches. 8 inches was selected for Bell Park Road because that is at the northern end of the subdivision where the elevation is highest. As we move down, as we move south in the subdivision, the elevation decreases, which we can expect a higher flow rate, and therefore increasing the pipe diameter to account for that. Okay, so the total dynamic head that I calculated was approximately 50 feet, and then the flow rate expected to be 520 gallons per minute. Using the pump curve shown on the screen, I selected the Gold 4S pump, and in that calculation, I have an efficiency of 67%. This is typical for pumps that are in lift stations, and ideally you want the range to be anywhere from 60 to 80%. Here's a plan view of the lift station. As highlighted in the yellow text, there are 2 pumps that are located in the wet well. That is for redundancy purposes. The wet well diameter was calculated to be 14 feet. And then there is a pipe that is exiting the wet well that helps with odor control. And then as you can see on the right side of the screen, the 4-inch force main. Lastly, we have the bank stabilization system that was used. As mentioned in previous presentations and reports, I selected rock gathering baskets. This system will span the length of the creek, which is approximately 2,600 feet. And through proper maintenance, we can see a design life of approximately 75 years. The USDA requires that for bank stabilization systems to have a design life of 20 years, so we are well over that. Then, using RS means, I generated a cost estimate of approximately $1.5 million, as you'll receive the itemized breakdown on the screen shown here. Thank you, and with that, I'll hand it over to Grace.
At this time, I'd like to open the floor for any questions. Yes.
Okay, Jibril, looking at the pipe sizes in there, can you show me like a plan view? I want to see the routing of, go back now, a plan view. Flow path.
Okay.
No, you should, for the arrows, yep, this one in here. So can you just guide me through how the flow gonna go? So if I am on Vale Park Road, why do you take the flow into like the Old Oak rather than continue on Vale Park for the northern section?
That's a good question. So I determined this based off of the contour lines for the Porter County GIS website. The elevation where the building is, it was determined to be about 810, 815 feet. And so the lift station is located at 760 feet. So the wastewater is moving in a decreased elevation to take into account gravity flow. Does that answer your question?
Yes, actually, and that's the reason I'm reflecting on what Dana presented, and she more or less put her lift station in a different location and more or less going uphill along like Old Oak Drive compared to this route in here. And
yeah, I mean, there's different elevation points that can be selected. There's various ways to have the system organized, and so this was just kind of like what I chose to do.
Thank you. That's it.
So since you're answering questions, Jibril, and maybe for Dana too, what's so special about the drawings from Cary, North Carolina Do they have like a monopoly on buildings?
Yeah,
Yeah.
they do. So it was really nice. In this case, I had permission from my technical advisor to go ahead and edit the pre-existing drawing. Actually, both of us did, and we edited them to fit our system needs. So had to give credit for that.
Okay, thanks.
Yes, Leah?
Does the town of Cary, North Carolina, have anything to do with Katie's father, Cary Schreiner?
100%.
That's what I thought. Thank you.
Yes, question.
The floor slab, you said there's spacing of number 4 is at 12 inches.
Yes.
What does that mean exactly?
The rebar that was selected is number 4 size, so it's about 5.5 inches in diameter, and it will be spaced 12 inches across. So from one part of rebar, it will be spaced 12 inches to the next one. And the floor is designed to have it going both perpendicular and parallel.
Okay, that's what
Yeah, yeah. You can see in report 3, I do have a diagram that shows where the rebar is going to be spacing and how it will be spacing, but yeah, it will have going both parallel and perpendicular.
Okay, thank you.
I think Andrew's slide 26. Is that your slide? What's that object underneath the word access?
I believe that's probably a small body of water.
Okay.
Again, I'm not a water resource person, so it wasn't within, you know.
Okay, I just think, yeah, okay. That's all. I was wondering what that was.
Katie.
Could you please describe your company's business model?
Survival of the fittest. We strive for excellence and we don't accept anything less.
Okay, and going off of that, what is your estimated profit margins on this project?
Could not tell you off the top of my head. Yeah.
I actually said I don't have a question, but changed my mind. So could you please go to the like plan of the like arrangement of those brace frames?
Yeah.
As a matter of fact, I'm fully aware of what you did, so this is just for the sake of like evaluation of how you answer your questions. To the plan, not evaluation. One more. Oh, yeah. So why did you decide to, because your brace system is completely symmetric, why did you decide to add 2 more brace systems in the entrance part?
To make it laterally stable. So when I was doing my RISA model, the only way to get the building to be stable was to actually brace those members. Otherwise, I was getting an error where it would be saying, you know, the building will stand.
Thank you.
Any other questions?
Thanks.